Cast your mind back to the dark ages. And by that, I literally mean the early 2020s. Think about it for a second. We carried these incredibly powerful, sleek supercomputers in our pockets, yet we spent half our day tethered to walls like hostages, desperately negotiating with a power outlet. Well, thankfully, we have officially escaped the tether. Today, we are tearing into a definitive technical explainer on the 2026 global wireless charging and MagSafe ecosystem. We're going to break down the raw physics, the intense global brand rivalries, and the exact specs you need to know to completely future-proof your tech setup.
Seriously, if you're still physically plugging your phone into a wall, it's time for an upgrade. What we're witnessing right now in 2026 is a massive industry-wide paradigm shift. We've moved from tethered necessity to what the experts are calling ambient availability. Remember those early, super clunky wireless charging pads? They were basically just dumb hot plates. You'd put your phone down, pray you hit the microscopic sweet spot, and wake up to a device that was either totally dead or hot enough to fry an egg. Well, the days of having to choose between charging efficiency and actual convenience, those are entirely over.
All right, let's jump right into Section 1, Q2.5, the thermal revolution and the physics of 2026 power transfer. Okay, so let's look at the hardcore engineering that actually made this huge leap possible. The absolute secret sauce of the Qi2.5 standard is BDN, or Bi-Directional Adaptive Negotiation. I know it sounds incredibly dense, but just think of BDN as this tiny, highly trained, encrypted diplomat living inside your phone. Through an NFC backchannel, this diplomat is constantly talking to the charger, actively negotiating the voltage in real time. In the old days, chargers just blindly pushed power until your phone overheated and thermally throttled itself down to a useless trickle. BDN entirely eliminates that. The diplomat steps in, says, "Hey, getting a bit warm here, let's dial it back for a couple of seconds," and completely stops the charger from setting your device on fire, all while maintaining maximum safe speeds.
But listen, a brilliant software protocol is literally nothing without extreme hardware to back it up. The transmitters in 2026 are powered by high-frequency gallium nitride, or GaN, integrated circuits. This tech pushes frequencies way past 300 kHz, slashing heat generation and increasing the Z-height, meaning you don't need millimeter-perfect contact anymore. And we aren't using standard cheap fridge magnets for alignment either. We are talking sintered neodymium iron boron magnets. They boast enhanced thermal stability, which means even when you're pushing intense 50-watt rapid charging cycles, your alignment remains completely flawless. If you crack open a 2026 flagship charger, you'll see they aren't passive pieces of plastic anymore. These things are sophisticated thermal engines. We're talking integrated vapor chamber cooling built right into the charging pucks themselves. When your device is detected, these chargers actually spin up microfans or activate solid-state Peltier coolers. It's like a microscopic refrigerator dedicated purely to keeping your battery's skin temperature safely below 35 degrees Celsius. This kind of active cooling is absolutely the only way to sustain 30 to 45 watts of wireless intake without rapidly degrading your lithium polymer cells over time.
Let's ground all this incredible engineering in some hard data. Just a few short years ago with Qi2, we were maxing out at a standard 15 watts of output using really basic in-band FSK communication. Now, the baseline for Qi2.5 is safely pushing 25 to 35 watts using that secure NFC and Bluetooth LE backchannel we just talked about. And those proprietary high-end chargers, they're pushing anywhere from 50 to a mind-bending 100 watts of power. It's a blistering pace of innovation, and it's setting the stage for how wildly different regions around the globe are handling this technology.
Moving on to Section 2, Apple's MagSafe hegemony and the Americas' invisible integration.
Starting our global tour over in the Americas, Apple has established what analysts are calling invisible integration. The crucial point about Apple's 2026 iteration, MagSafe Ultra, isn't actually just the power, it's the data. They're utilizing a proprietary frequency band to achieve something that was previously thought impossible due to magnetic interference: data over power. Seriously, let that sink in. You can now slap a magnetic drive right onto the back of your phone and wirelessly back up a massive 8K ProRes video file while simultaneously fast charging the device. It is an absolutely massive workflow upgrade. It allows for charging and data syncing to be seamlessly built directly into workstation surfaces, vehicle consoles, and premium furniture without a single cable in sight.
Next up is Section 3, Europe versus Asia charging, or as I like to call it, utopian surfaces versus brute force. Jumping across the ocean, we see wildly different approaches.
In Europe, sustainability and open standards are absolutely king. The European Commission actually mandated universal solutions, which led to the key-ready legal requirement for all public infrastructure. And the magic number over there is 6.78. They've aggressively deployed resonant surface technology running at a 6.78 megahertz resonance. This means you don't even need a specific charging pad. You can walk into a cafe in Berlin, toss 2 phones and a pair of earbuds literally anywhere on the table, and they will all charge simultaneously through 50 millimeters of solid wood. It is seamless, public, ambient power at its finest.
But hey, if you want to see the absolute bleeding edge of speed, you have to look to Asia. Brands like Xiaomi, Oppo, and Vivo aren't worried about wooden cafe tables. They are out to conquer the speed frontier. Their magic number is 100. Commercialized 100-watt wireless flash charge. Using insane dual-coil architectures and customized charging pumps, these devices take a massive 5,000 mAh battery from 0 to 100% in under 20 minutes, wirelessly. It's a slightly fragmented ecosystem over there for sure, but in terms of raw brute force engineering metrics, they are lapping the rest of the world.
Which brings us to Section 4, Expert Future-Proofing Metrics. Here is your 2026 Prosumer Buyer's Guide. So how do you actually use all this information to shop like a pro and ignore the marketing fluff? Well, when you're evaluating chargers, here is your ultimate checklist. First, demand multi-coil arrays. If a charger doesn't have multiple coils, do not buy it. You'll just be back to the sweet spot frustration of the early 2020s. Second, look for PPS, or Programmable Power Supply Protocol over wireless. This is absolutely non-negotiable if you want to maximize the lifespan of your battery. Third, check the magnetic pole force. You need a minimum of 12 newtons. Anything less, and your heavy flagship phone is going to slowly slide right off that expensive floating desk stand. And finally, the ultimate future-proofing tip, software-defined power, or STP. These are chargers that receive firmware updates directly through your smartphone. So when Q3.0 eventually drops, an SDP charger just updates itself. No new hardware required. It's brilliant. Finally, Section 5, the spatial power future, and our conclusion, toward ambient power. As we wrap up this explainer, we really need to look past our current magnetic standards. Qi2.5 and MagSafe Ultra are spectacular, no doubt, but they are just stepping stones. The report summarizes this evolution beautifully, with this profound realization. The wire is now a legacy fallback, not a daily necessity. Just let that resonate for a second. We have officially severed the umbilical cord. High-frequency inductive charging has peaked, offering unparalleled efficiency and user experience.
So what comes next? Are you actually ready for true spatial wireless charging? Because make no mistake, that is the real sci-fi endgame we are sprinting toward right now. Imagine walking into your living room and invisible infrared or radio frequency beams securely and safely identify your devices and just begin charging them from across the room, straight through the air. The era of the plug is definitively over. The era of true ambient energy is just beginning. What are you going to do with all that untethered freedom? Keep learning, keep upgrading, and I'll catch you in the next explainer.